Hello guys, welcome to our class today, and we're going to look at a problem of the mole. So dealing with the stoichiometry. Stoichiometry is the relationship of reactants and products in a chemical reaction. What you need to know, you need to know every chemical reaction, reactants and the products. So we can solve this problem by using the knowledge that we did before so that we can solve this problem. Let's go. It goes 5-gram sample of impure magnesium carbonate is reacted with excess dilute acid. So it means that the carbonate is impure. At first, the carbonate is impure. It's not pure. So it contains other constituents that are not magnesium carbonate. It's reacted with excess dilute hydrochloric acid. So magnesium carbonate with dilute hydrochloric acid, the product formed are magnesium chloride plus carbon dioxide plus water. Balancing the equation, chlorine is 2. We put a 2 here to balance chlorine. H is 2, it is 2, oxygen is 3, it is 3, magnesium is 1, here is 1. So the equation is balanced. 1250 centimeter cubic of carbon dioxide is collected at RTP. 1250 of carbon dioxide is collected at RTP. Remember, RTP means it's room temperature and pressure, which is 0 degrees Celsius, not 0. Room temperature is 25 degrees Celsius, comma 1 atmosphere. So these are the conditions for room temperature and pressure. So you get that the volume of carbon dioxide produced is 1250 centimeter cubic. We know that we looked at gases, molar gas volume. 1 mole of gas. So here, how many moles of carbon dioxide are produced? So 1 mole of a gas is 24,000 centimeter cubic. What is collected is this gas that is collected here is carbon dioxide. What about 1250 centimeter cubic? What number of moles are produced there? So you ask yourself. So that is 1 times 1250 over 24,000. So you calculate the number of moles of the gas that is collected. 1250 divided by 24,000, you get 0.05208 moles of carbon dioxide that is produced. Then we go to the next question. What is the mass of pure magnesium carbonate will be given the volume of carbon dioxide? What mass will have been used? What mass of pure magnesium will be given this? What mass of pure magnesium carbonate will have given this volume of carbon dioxide? Therefore, we use ratios. So magnesium carbonate is ratio 1, carbon dioxide is ratio 1. So mole ratio is MgO carbonate, that is magnesium carbonate, to CO2. The ratio is 1:1. From the equation, there's no coefficient here. There's no coefficient here. It means that 1 mole of magnesium carbonate gives 1 mole of carbon dioxide. Since ratio is 1:1, therefore moles of magnesium carbonate used are the same. So with that of carbon dioxide, therefore moles used is 0.05208 moles of magnesium carbonate that is used. How can we calculate mass? Mass is equals to moles times molar mass. What we do now is to calculate molar mass of magnesium carbonate. That is MgCO3. Mg is 24. C is 12. Oxygen, there are 3, so that is 16 times 3, giving us a molar mass of, let me calculate that, 24 plus 12 plus 16 times 3, the answer becomes 84 grams per mole. That is the molar mass of magnesium carbonate. Calculating the mass now, because we had moles, mass is, calculating the mass is moles times molar mass. Therefore, it will be 0.0 5208 times 84. What is the mass that you will get? Let's calculate that times 0.00528 at 0.052. So it is 84 times 0.05208. It will be 4.3747 grams that is used in the impure carbonate. Therefore, the pure carbonate used is on the impure sample. So the pure carbonate that reacted is 4.3747. This is stoichiometry, relationship of reactants and products. So this is the mass that of magnesium carbonate. What is the percentage purity now? Percentage purity is equals to mass of pure over the total mass, which is the mass of the sample, times 100%. What is the mass of the pure that we calculated? Was 4.3747 divided by 5 times 100%. So this is the percentage purity, because we had the impure sample, which is 5 grams, and this is the mass of the pure that reacted. We have used mole ratio and stoichiometry, relationship of reactants and products, to find that. So calculating that, that is 4.3747 divided by 5 times 100%. The answer becomes 87.494%, which is the same as 87.5%. Therefore, the mass of magnesium carbonate in the sample, 5 gram sample, is 87.5%, and the other constituents will be that 12.5%. So this is how we calculate it. Thank you. Let's meet in our next class to do more problems that will help you find this and understand these questions. Thank you. Let's meet in our next class.